Greetings to you, my beloved learners. I welcome you to this wonderful platform, the class of science. Okay, so today's lesson, we are looking at questions that comes in paper 1 under this topic, measurements and quantities. Okay, so this is how the examiners set question under measurements and quantities. Remember, in science, paper 1 is physics, paper 2 is chemistry. So when you hear paper 1, it means we are working out questions from physics as a subject. Okay, so quickly let me run you through the questions that we have and see how we can best answer these questions. Pay particular attention so that you can understand everything. Okay, so question number 1. A measurement cylinder contains 30 centimeters cube of liquid. When a stone of mass 92 grams is dropped into the liquid, it sinks to the bottom and the liquid rises to the 70 centimeters cube mark. Question number 1. What is the volume of the stone? 1 mark. B. Calculate the density of the stone. 1 mark. C. Explain why it would not be possible to use this method to determine the density of the cork which would float in the liquid. 1 mark. So on this question only, we have got how many? 3 marks. So let us actually pay a particular attention as I said, so that we can move together. Okay, so I think I'll get this bottle, okay, representing the measuring what? Cylinder. Representing the measuring cylinder. So according to the statement, they are saying this measuring cylinder has got water. It contains water of this volume, which is 30 centimeters cube. For example, we have this. We are going to assume this is 30 centimeters what? Cube. That is the water which is in this particular measuring cylinder. And this is how the measuring cylinder looks like. Okay, so this is 30. Now we get a stone, okay, a stone which has got the mass of 92 grams. So now we are going to assume we are now lowering the what? The stone which has got this mass, which is 92 grams. So when you drop into this particular measuring cylinder, that stone is going to go direct at the bottom of the what? The cylinder. And automatically, okay, practically, water now is going to rise from this level, going up. So now, according to the statement here, they are saying, when that stone was dropped, water raised up to 70 centimeters cube. So we are going to say somewhere here now. This is now the volume of this measuring cylinder. Okay? Now the question says, what is the volume of the stone? Okay, so what I can encourage you is, you must know that when you are handling examination questions, or when you are in an examination room, whenever you are given a question, first of all, you need to understand that question. Okay? Once you do, then you'll be able to do what? To give the correct answers. It is very, very important. First, understand the question, then do what? Start answering. So like the way we have understood this question, by demonstrating the measuring cylinder, now it will be very easy for us now to know the volume of what? The stone. So what are we going to do? So we are going to mark, okay, the first volume before the stone is sunk. We are going to name it as volume what? Volume 1. Okay. Now, when the stone was dropped, okay, in that particular liquid, the water raised to a certain what? Volume, which is 70. So this one, we are going to name it as what? Volume what? 2. You understand? So now, for you to know the volume of this stone, you have now to subtract. You are going to subtract the final volume, which is volume 2, minus the initial volume, which is volume 1. So now let us get the values that we are given here and substitute. So the volume 2 is 70. So we are going to say 70 centimeters cube minus the first volume before the stone was what? 30. Okay, 30 centimeters cube. Okay, that is the way to go. Then from there, you are going to say 70 centimeters cube minus that. What is the answer? The answer will be 40 centimeters cube. And this will be the volume of that particular stone, which was dropped in that measuring cylinder. Okay, so it means here we have gotten the 1 mark. Then we go to the next one. Question B, they are saying calculate the density of the stone. So remember, when calculating the density of the stone, there are 2 things that you make sure that they are present. What are those? 1, you should have a volume. Okay. 2, you should have a mass. Okay. Now, when you look at the statement that we have here, we are given the mass of that particular stone. It was 92 grams. Now, the volume again you have calculated. No wonder why examiners here, they started first of all by asking us to calculate the what? The volume. Okay. So we have those 2 important things. Now we go direct to the formula for the density. Here we are calculating the density of the stone. Okay, so density of the stone, D, is equals to mass over volume of that same stone. So let us substitute. Okay, this is A, this is B, I mean, and this is A. Okay, this is A. Let us substitute. So there we are going to say the mass is 92. So we are going to say 92 over. Then the volume is what? The volume is 40. 92 grams, then 40 centimeters cube. You know, in physics, units are very, very important. Make sure you write the necessary unit, even to the final answer. Very important, because just unit can cost your mark. Okay? Yes. So now, when we say 40 into 92, what is the answer? The answer is 2. Okay? Remember what? 40, that is 80. So we are going to say remainder 10. Okay? Remainder what? 10. So again, we are going to say 40 into, remainder 20. 40, remainder 12. Because when we say 80, then the remainder will be 12. This is 92, remember. So here we are saying 12. 12 is our remainder. Okay? So now, 40 to 12, it can't. What do? We are going to put a point first here on the solution part. Then we add a 0. The moment you just put a point here, this is mathematical concept. Okay? Remember, physics is also for what? Numbers. So the procedure is just the same. So here we are going to put a 0. So when we say 40 into 120, the answer will be 3. Okay? 3 what? Remember now the units. We are dealing with the mass and the what? The volume. So the answer will be mass, grams per what? Centimeters what? Cube. That will be the density of the same what? The same stone that was dropped in the cylinder. Okay, so now we are coming to the last part of our question. Okay, so question C. Here now they are saying, explain why it would not be possible to use this method to determine the density of coke, which would float in the liquid. Why? Why is it that using this method, which we were using here, to find the density, was not going to be possible to do what? To determine the density of the coke, which would float in the liquid. That one is straightforward. Okay, if you have logical reasoning there. This one, the coke, when you drop it in the cylinder with water there, automatically this one is not going to sink. And what will happen to the level of water? Water will maintain the same what? The same volume. There will be no volume which will be displayed. Therefore, we are not going to have the what? The volume. Now imagine if you don't have a volume, even if you have a density, is it possible that you can find the density? Even if you have a mass, it is not possible. So that one is causing us not to use this particular method for us to find the cork which can't sink in the liquid. Okay, so we are going to put this one like this. This is C. I'll use this part now for C. Okay? It would not be possible because there will be no volume displayed. Okay, so it would not be possible because there will be no volume displayed. If you don't have a volume, you can't find the density of a particular object. Now, if you have volume and mass, then it will be very easy for you. Remember, for you to find the density, it is mass over volume. Okay, so thank you so very much for listening to my lesson and following step by step. Thank you so very much. See you in the next class.